we're going to be looking at applications of the sine and cosine waves. Not so much the other ones, because sine and cosine waves we actually see a lot in real life applications. So we're going to start out with this Ferris wheel. The Ferris wheel itself is 60 meters high, and it takes for every rotation, it takes 4 minutes to do a full rotation. So what that means is that it's going to take 4 minutes for this one right here to go all the way around and get back in that position. So what I want you to do is, with your partners, discuss and then sketch what the graph would look like in respect to time. What would the graph look like in respect to time? Now make the assumption that either A, you are starting in that down position and you are this person in this position at the very down, or you're at the very top when you start it. That will be the easiest way to think about how you would graph this thing. So with your partners, discuss how you would graph what the shape would look like if you were on the Ferris wheel. So the distance away from the ground with respect to time. So this is the distance from the ground, and this is with respect to time. So go ahead with your partners around you, graph what you think it would look like. And again, you either want to start at the very top of the Ferris wheel, or you want to be at the very bottom of the Ferris wheel. Do you understand what I'm asking? Okay. All right, so for this, where has my baseline moved up to? 40, because it tells me the Ferris wheel is 40 feet off the ground. So my baseline has moved to 40. So here's where my baseline is. My diameter is 60. That means that my maximum height when it happens will be at how high? 70, because what I have is, since this is 60, the radius is going to be half of that, so that's going to be 30. So your max height should be your baseline plus whatever your radius is. And in this case, my radius is my amplitude. So my max height will be my baseline plus my amplitude. So that is my max height. What is my minimum height then? 10. Because it is my baseline minus my amplitude will be my minimum. If it takes 4 minutes to do a full rotation, so where am I at time 0? Where am I? So if I choose being at the bottom of the Ferris wheel, then I'm going to start at 10 meters off the ground. And then after 2 minutes, or even 1 minute, after 2 minutes, where am I after 2 minutes? I'm at 70. At 4 minutes, where am I? So at 4 minutes, I'm back to 10. As you are doing this, if you did a second rotation, where are you after 6 minutes? And where are you after 8 minutes? This is what your graph should look like. It's a sinusoidal wave. Now you can either think of this as being a cosine wave, or you can think of it as being a sine wave. I see this and I say, oh, this screams cosine. Yes?
What if you started at halfway up on that?
So if you decided that when you're starting your time, and you're already at the halfway mark, then yours is going to be more like a sine wave, right? So it's going to take you 4 minutes to get back to the halfway mark, or back to your baseline, if that's the way you're going to do it. And your sine wave is going to be go into a negative. So at the 2 minute mark and the 4 minute mark, you're back right here at the halfway or the baseline. And yours is going to look something like this. So if that's how you've seen if you decided you're going to start paying attention to your height, when you are at the baseline, then you have that wave.
Oh, but that's like if you're starting midway and going back towards the ground?
Yes. So if you were starting on this side, that's what it would look like. Now if you decided that you're going to start on the other side, that you're going to start paying attention to your your graph when you're on the upswing, so it's this side, then yours would look like this. So it just depends on how you look at it. Most people think about the height when they get on at the very bottom and then go to the very top and then come back down again. So it doesn't matter how you look at it. By convention, we usually say we're going to start doing the measurement of height when I get on the ride. But if you did it as soon as I get the halfway or the baseline, then you can definitely have that as well, and that'd be the green one. If you decided you're going to be doing it as you're coming down from the baseline, then you would have the red graph. Does that make sense?
Yeah, and so since you're already halfway up there, your maximum would be 1 instead of 2.
Yep. Yep. So all of these, whether you think of it as you're getting on and you start measuring it from the bottom, or you start measuring it when you are on the upswing at the baseline, or you're in the downswing from the baseline, they all can be wrote in terms of a sine or cosine. So when we say sinusoidal, it means we're talking about a sine wave or a cosine wave. So if I decided that I want to describe my blue graph in terms of cosine, because that screams cosine to me. And the reason this screams cosine to me is because I'm starting in a minimum. Cosines either start in minimums or they start in maximums. They start at the highest point or the lowest point. If I decide that the blue graph to me looks like a cosine wave, then the first thing I have to do is determine what the period is and whether or not I have a phase shift. So I'm going to look at the blue one and the blue one only. So let me get rid of some of these other colors here.
If that's cosine, wouldn't it have to have been reflected?
Yes, and we'll get there. So let me put the blue one back on here. And I'm going to go down. I'm going to start at 10, and then at 2, I'm at 70, and at 4, I'm back at 10. So here's what my cosine wave looked like. I did it better drawing the first time. Let me try that again. Much better drawing the first time. Okay, so I'm just going to focus in on that part. I think this looks like a cosine wave to me, so yes, I do have a reflection. But I do need to figure out whether or not I have any kind of period change. So the first thing I do is I determine how long it takes to go because it's a cosine, from a max to a max or a min to min. How long did it take to get from a max to a max or a min to a min? Took me 4. So I know that my period, P, is equal to 2 pi divided by omega. Now, I'm chasing omega because it's right here. I need that omega. So I take my distance traveled from max to max or min to min, in this case, happens to be 4. And I set 4 is equal to 2 pi divided by omega. So now I have to figure out what omega is. And I do that by multiplying both sides by omega and dividing by 4. So my omega is pi divided by 2. Do I have a phase shift? The answer is no. I do not have a phase shift. I am not moving my cosine wave left or right. And if I would have chose sine, I wouldn't have been a movement left or right for the sine either. The next thing I want to do then is talk about the movement up. How far up did my base go? My baseline go to? Where is my baseline? At 40. So my baseline, or my B value, my movement up is 40. How big is my amplitude on this one? 30. So my amplitude is 30. It takes me, I go up 30 and down 30 from the baseline. The diameter is 60, but the amplitude is half of that. And the last thing is, I need to account from the negative. So I'll put on a negative 30 there. That way I start in a minimum instead of a maximum. So my final graph then is S of t is equal to negative 30 cosine pi over 2 times t, and then plus 40. And that's my final sinusoidal equation for that. So as you're thinking about your writing of your exam, here's an application, here's a transformation of graphs in one question. So I have a transformation of graphs and I have an application in one question.
What's the T for?
Because it's in respect to time. It's the time, it is the Ferris wheel height is changing with respect to time, so we use the variable time instead of x.
So is that why you don't factor out the pi over 2?
Well, I don't factor out the pi over 2 because this is at the omega. So it is my period change, so I don't factor out a period change unless, of course, if I would have had, let me erase some of this stuff. If I would have had a phase shift, then I would have dealt with that factoring out business, is what you're asking me, I believe.
Yeah.
So I don't have a phase shift, so that's why I don't have to factor it out. If I had a phase shift, then I would have factored that out. The only time I have to worry about factoring off the omega is when the omega has, or when I have a phase shift included and this one doesn't. So I don't have to write it like this. I think what you're asking me is, how come I didn't write it like this? S of t is equal to a cosine, and it doesn't matter if sine or cosine, omega x or t minus, so t minus my phase shift plus b. The only time I have to worry about factoring off the omega is when I have a phase shift. This one doesn't have one.
Okay, so then does that period times t, does that mean that for every amount of time, or in a measure of time, there's a full cycle that occurs in pi over 2? Like, what does that mean?
It means I have a period change, so instead of going from 0 to 2 pi, I'm going from 0 to 4. The omega is your period change. So if that wouldn't have been pi over 2, if I wouldn't have had pi as a multiplier as my omega, then I would have had to find numbers in terms of pi. And we usually don't count in terms of pi.
So the period change is pi over 2?
Divided by omega for sine and cosine.
But I thought we were divided by omega, so we got pi over 2.
No. Sine and cosine start out with periods of 2 pi divided by whatever your omega is. So all sine and cosine waves have period of 2 pi.
Right, but after we divide by omega, is that a new period change?
That is the period, yes. That is your new period, yes.
So there's like a full rotation every
4 minutes.
every half pi of them?
Every 4 minutes. How we find our period change for sine and cosine, our period is 2 pi divided by omega. For the most part, omega is 1. So our period is 2 pi. In this case, my period, or my omega, 2 pi, is going to be pi over 2 because I need this thing to take 4 minutes to do a full rotation.
And that's happening every pi over 2?
Every 4 minutes.
Okay, but how is it, what is the pi over 2 doing? Like, what is it, like, that's the period, right?
Before the period change. That is the standard period before it changes. So I'm not sure if I'm answering what you're asking, and I'm not sure if I understand what you're asking.
You're saying, like, the end thing that you wrote there, pi over 2 times t, what is happening in pi over 2? That's the new period?
No. No, that is the change. That's changing the period. The new period is 4 minutes, but the change is happening because the omega is pi over 2. Pi over 2 is the change in your original 0 to pi over 2. It changes your period. It's a horizontal shrink or stretch. So if you think about it in pre-calc 1, we would have called that B, and we would have said that's a horizontal shrink or stretch. So that omega is a horizontal shrink or stretch. It is changing your period horizontally. Your period should always start at 2 pi or go to 0 from 2 pi. Because my omega is something other than 1, then I am doing a horizontal shrink or stretch. And in particular, what I'm doing is because I'm going from 0 to 2 pi is slightly more than, well, it's like 6.5, well, 7. and I'm shrinking it down to 4. So it's actually a horizontal shrink. I'm shrinking my period. And I'm writing it in terms of something that we normally would write it in, which is minutes. Right? 1 minute, 2 minute, 3 minutes. We don't say pi minutes. We don't say 2 pi minutes. If I go out to my family tonight and I said it's going to take me 2 pi minutes to finish dinner, they'll understand because they're a bunch of math geeks. But almost nobody else would. In fact, they'd laugh at me and think, Mom, you're spending way too much time at school.
So that pi over 2 is the amount that our original period has been reduced by?
Pi over 2 is the original one. The pi over 2 is a reduction, yes. It is a horizontal reduction of the original period. We good? Somewhat? Yes.
So we can actually put this right here on the test.
You can put it verbatim on the test if you like it.
You know, so if we're writing our answer key for this, do we have to write out the multiple different answers, or do we just do one? We have to do like how many are this?
There's an infinite amount, depends on how you look at it.
So we have to write
So I would just write a sine one and a cosine one.
Sine one, okay.
Yeah.
Oh, and can we like on our test we put like hints, you know?
I need to work on that poker face. It is probably best not.
Okay.
All right. Okay, so we just did that sinusoidal example. Here's another one. I want you to do this one on your own. See if you can come up with this one. It is the London Eye. If you've ever been on it, it's slow as heck. Have had the opportunity to be on it, and I'm just like, oh, I don't like these people I'm on this with. And they were my own family. So you're on it for 30 minutes together. Exactly, with your family. And you just get off and you think, man, where's that London gin I hear about all the time? So try this one, please. You all, that this is the first time you're seeing it, so I expect you to struggle. Every time you struggle, you learn. If you came walking in here and you knew how to do all of this stuff, you're in the wrong class. You should be in calculus. You shouldn't be in here. So if you're struggling, that's okay. It's okay to struggle. It's totally fine, and I expect that. I don't expect everyone in here to say, oh, good, I know it's going on all the time. That never happens in any math class. And if it does, you're probably the teacher, and even then we have times like, what's going on?
All that were true, I should be the smartest person in the world.
Okay, so on this one, how many of you, did anyone choose the sine wave? Cool, because it screams cosine, doesn't it? So if this thing screams cosine, what is my amplitude of this? Negative 67.5. Can you tell me how you got that amplitude?
I just cut the diameter in half.
I cut the diameter in half, and that means that I have 67.5 is going up and then going down because it has a total of 135. And you all use cosine. And then what is your omega? First of all, is your omega something other than 1? Yes. What is your omega?
30.
How did you all get pi over 15? So 30 is equal to 2 pi divided by omega. And then you solved for omega. My period total is 30 minutes. It takes 30 minutes of joy and fun with your family, sober, on the London Eye to go all the way around. That's one period, is one full rotation. Do we have a movement up or down on this one?
Yep.
Do we have a movement up or down on this one?
No.
No. Why does this one not have a movement up or down? Because it says your lowest point is ground level. So unlike my previous Ferris wheel where I had to walk up a ramp or walk up steps to get on the Ferris wheel, the London Eye is in such a way that they expect people to be able to just walk right on or put their wheelchair right on without any work. So the London Eye, you just physically just walk on at ground level. So the Ferris wheel actually, the bottom part of the Ferris wheel is slightly a little bit underground, but you're going right in there at ground level. You walk right in at ground level. So there is no movement up or down on this one.
Even though our midline is at 67.5, there's
Yeah, because if you ever look at pictures of the London Eye, it is literally right there at ground level. So you can walk right on.
But that doesn't seem that much different from what we did before.
Well, the one we did before says the midline is, or the height of the center is 40 feet up. So if you ever go to a fair and you got on a Ferris wheel at a fair, they're never at ground level.
Right.
They're always so many steps or so many things up.
There would be a difference of like 3 feet at the most.
Right. In this case, this has been moved up to, oh yeah, sorry, yes, I see what you're saying. It does have a movement up.
Okay.
I was thinking, yeah, it does have a movement up. You're all like she's on crack. No, I was having PTSD about my ride. So, I really need to stop bashing on my family. Anyways, so I do have a movement up, thank you, and it is 67.5. Now you're all good. Before you're like, crazy, she's a crazy. Okay, let's take a look at this one. How do you think I'm going to take a look at this? How do you think I'm going to do this one? Put it in Excel, hope it graphs it for me. What did I do on the previous two examples to determine whether it was a cosine wave or a sine wave? What was I looking for? I looked for a maxima or a minima, right? And how far it took me to get to the next one? What do you think you're going to do on this? How long does it take me to go from max to max or min to min? And that's going to be what?
8 months.
That's going to be what?
Period.
It's going to be your period. It's not going to be omega, but it's going to be your period. So go ahead and try this one. All right. So how many of you all used a sine wave to describe this? That's fine.
Well.
You're not wrong. Tell me how you did it then.
Well, I didn't.
Okay. How did you start it then? How did you start it with a sine wave?
Well, it's a good question. I was kind of looking for the minimum and maximum,
Okay.
and then I found kind of the middle between those.
Okay.
And I didn't have baseline for it.
Okay, cool. So you took how long it took from a min to a max, right? So what did you choose as your min? 33 degrees. What did you choose as your max?
74.
So you took those, and what did you do with them?
Took 74, subtracted 33, and had a baseline between max and min.
And so when you did that subtraction, what did you all get?
53.5?
You got 40? 41. Okay. Now that's the distance traveled from max to min, or min to max.
You divide that by 2, you got the
And I divide this by 2 and I get the amplitude. And what'd you get for the amplitude then? 20.5. Okay? So the amplitude is going to be the halfway between the min and the max. So that's the amplitude. How did you find your baseline? So you took your amplitude and you added it to your lowest value. So your baseline is you did your lowest value, which is 33, and you added your amplitude to it. And so you end up with 53.5. So that's where your baseline has moved up to. So that is your B value. We know your amplitude. How long did it take to go from a minimum to a maximum?
7 months.
It took 7 months. Now, that should be, for a minimum to a maximum for a cosine or a sine, should be half of the period. Does it make sense for this to be 7 months, however, in real life? No, because what's going to happen is if you consider it being 7 months as your half your amplitude, in other words, 14 months for your amplitude, at some point, your summer months, quote, your summer months will start having the freezing temperatures, which we know that doesn't happen. So even here in Centralia, where it's pretty much just rain all day long, all year long, at 55 degrees all year long, we still know there's summer somewhere. And we get a day. We actually, look, we have sun today, rain tomorrow. So here's our summer, enjoy it. Actually, here's our spring, enjoy it. We're going to go back to winter tomorrow. But we know, how long does it take to get to summer? How long does it take to get to winter?
3 months.
So from summer to summer, winter to winter, how long does it typically take? 12 months. So because these are temperatures in terms of time, my period is going to be 12 months. So even though this particular year, this snapshot took 7 months, typically it'll take about 6 months to go from a minimum to a maximum. So a minimum to a maximum will take about 6 months. It should on average be 6 months. So that means, what is my period? 12. So my period is 12. So then how do I find my omega? 12 equals 2 pi over omega. So what is my omega? All right, so now let's bring this all together. So I have an amplitude of 20.5. Does it matter where I start this? Not really. If you consider your summer months to be your starting point, then you have no phase shift and you don't have any amplitude change other than a positive 20.5. So if you decide your summer months, you're starting in the summer, then you're just going to write the regular cosine wave. If you decide you're starting in winter, you're going to start with a negative. So it depends on how you look at it. So we're going to write this as f of t is equal to 20.5, the cosine of, what was my amplitude, or my omega? Pi over 6t. And I'm choosing to start in the summer months, plus 53.5. And that's what I've decided my graph would look like if I start in the summer months. Now, if I started in the winter months, then the thing that would change is I would put a negative on that. If my starting point was the winter months, I would put a negative on that because I'm going to start at a minima instead of a maxima. So if I start in January, I put a negative on that because I'm going to start in a minima instead of a maxima. Okay? Does that sound okay?
So the graph would start going up from the midline?
No, this is a cosine wave. We did a cosine wave. So I'm starting, if I start in the winter months, I'm going to have a negative in front of it, and I'm going to start in a minima. If I'm starting in the summer months, I'm going to start counting, say, June 1st, and I'm going to end the end of May. So I have a cycle of 12 months. Then I'd have a positive there because I'm going to start in the higher month, the hottest month.
So it starts at 33 and goes up?
Yes, yes. Okay. This is undampened harmonic motion. So if you're going into physics, you will need to know this. We'll have a moment of just kind of reading through it. Just kind of give you a moment to read through it.